Hello students, welcome back to Bus Academy. Today I am going to discuss a new topic of linear algebra. The topic name is how you can find out the eigenvalues and eigenvectors of a matrix. Right? Let's start today's lecture. Before starting lecture, I'm going to write some steps. What is the basic step? What is the basic necessary conditions to find the eigenvalues of a matrix? The number one, for example, you have a matrix. The first condition for eigenvalues, matrix should be square matrix. Right. Number one condition, matrix should be square. Right. And number two step, to find characteristics polynomial. Right. For characteristics polynomial, for example, here is the matrix A. For characteristics polynomial, there is determinant of A minus lambda I. Right. So this is the basic, some steps of procedure. Step 3 is to find eigenvalues. Determinant of A minus lambda I is equal to 0. In other words, we can say that, for example, you have easily find out the characteristics polynomial. Then you can easily find out the eigenvalues when you put this characteristics polynomial is equal to 0. After that, we can find out the eigenvectors. If you easily find out the eigenvalues, you can easily find out the eigenvectors. For finding the eigenvector, there is A minus lambda I is equal to 0. Basically, we are talking about that is null of that matrix is equal to 0. So these are the steps, important steps. Number one step is you can find out the matrix should be square matrix. Number two is important. Alright, now we choose an example. For example, we have this matrix. Now we choose this example and find out the matrix and try to sort out this equation and find out the eigenvalues and eigenvectors of given example. So, the first step you have already mentioned that if matrix is square, first we find out the characteristics polynomial. First, for characteristics polynomial, determinant of A minus lambda I. Right. So first we've written as in A minus lambda I. The matrix A is this. Right, so we have the matrix 3, 1, 1, 3. Right, here is lambda, that is, here is the 2 cross 2 matrix, and the I is basically identity matrix. We can choose like this way. Right, so here we have 3 minus lambda, 1, 1, 3 minus lambda. Right, for characteristics polynomial, determinant of A minus lambda I. So that is determinant of A minus lambda I. Here is, that is 3 minus lambda, 1, 1, 3 minus lambda. Right. So for characteristic polynomial further discussion, you notice that 3 minus lambda I whole square, that is minus 1. Right. So now we sort out, here is the characteristics polynomial. If you sort out further, we obtain that is, which is equal to lambda square minus 6 lambda plus 8. So this is the required characteristics polynomial. Now we find out the eigenvalues. For eigenvalues, this must be equal to 0. So for eigenvalues, determinant of A minus lambda I, that is equal to 0. Now we put this matrix is equal to characteristics of polynomial is equal to 0. So here is lambda square minus 6 lambda plus 8 is equal to 0. If you notice that this is the quadratic equation, you can easily find out the factor, that is minus 4 lambda plus 2 lambda. Here is minus 2 plus 8, that is equal to 0. Here is lambda minus 4, here is lambda minus 2 is equal to 0, and lambda is equal to 4 and lambda is equal to 2. So we have obtained two eigen. For example, lambda 1 is equal to 2 and lambda 2 is equal to 2. Right. Now we find out these are eigenvalues. Which are eigenvalues? Alright. I'm going to remove this step. I'm going to remove this step and find the eigenvectors. For finding the eigenvector, we have already find out the condition. For example, the first value is lambda 1 is equal to 4. So here I'm going to remove this side for finding the eigenvalues. So we considered let here we can give the heading eigenvector. Let E1 be the first eigenspace. Corresponding to value lambda 1 that is equal to 4. If lambda 1 is equal to 4, by definition we can bring as E1 is equal to null of this matrix. Alright, got it. So here if you notice that we should put the values in this of an expression. The matrix is, so first we're written as A minus lambda I. The matrix is this, that is 3 1 1 3, that is 4 0 0 4. Right, the first, if you notice that here 3 minus 1, that is minus 1 1 1 minus 1. Right, so for now we use this definition for eigenvalues, for eigenvectors. For eigenvectors, A minus lambda I is equal to 0. So if you're written as this matrix like this way, minus 1 1 1 negative 1. So here is x1 x2, here is 0 0. Right, so now we write in written as this matrix in augmented form. Now we're written as this matrix in augmented form of matrix, in augmented form of matrix. So we obtain the matrix. Here is negative of 1 1 1. Here if I'm going to remove this side, we're going to written in this side. Right, so we have obtained the augmented form of matrix. So we have obtained negative of 1 1 1 negative 1. So we have 0 0 like this way. So we can solve it by reduced echelon form of the matrix. So first is minus 1 R1 plus adding R2. So you can easily sort out. If you're going to first step is multiply on both sides by minus R1, and second step is minus 1 or 1 plus adding R2. Right, so first step is 1 negative of 1 0 0, because this is then you can say equals to 0. The first step is that is 0. If you're going to multiply this term minus and this term is equal to that is 0. Right, so this is the basic criteria. You can find out the values. If you notice that here is x1 and minus x2. Right, so the first step you're going to multiply on both sides. So we have obtained matrix like this way, x1 that is minus x2 is equal to 0. Right, so here I have obtained like this way. Right, so for example, if you notice that x2 is a free variable, x2 is equal to t. We have obtained x1 is equal to t. Right, so this is the process. Now we're written in eigenspace. Now written is in eigenspace, so we can obtain the vectors. Let E2 be the second eigenspace. If E2 is the second eigenspace corresponding to value lambda equal to 2. So we can written as that is A minus lambda I, which is equal to, if you notice that the matrix is 3 1 1 3. Right, so minus here is a value 2 0 0 2. We have obtained the matrix like this way, 1 1 1 1. Right, so by definition that is n into 2, the null of the matrix. So here is x1, x2. The space of the matrix is 0, 0. Right? So augmented form of the matrix, here you obtain the matrix of like this way. Here is 0, 0. Right? Here I'm going to remove this side. If I'm going to remove this side, we can written as here. I'm going to remove this side. If you notice that here is the matrix, so we can solve this by reduce echelon form, normally matrix. So if I'm going to minus 1 R1 plus add in R2, so here is 1, 1, 0, 0. Here is 0, 0. So if we have reduced normally echelon form, so we have obtained that is x1, x2 is equal to 0. So we choose, it is depend on your condition. Rather than if, for example, I choose x2 is equal to t, then we have noticed that x equal to minus t. Right? So we can eigenspace we can written as x1, x2. Right? So we have obtained like this way. Here is negative of 1, 1 is equal to 2, such that t belongs to our number. T is real number. Basically, here is t is free variable. That means that t is basically a free parameter. We are talking about a free parameter. You can choose all the values that belongs to your real number. So we have obtained the vectors. So we have obtained vectors. The v1 is the first eigenvector, that is 1, 1, and v2 is equal to minus 1, 1. So which are the required eigenvectors? So which are eigenvectors? Eigenvectors. So we can also written in the form of matrix P. So we can written as 1, 1, negative 1, 1. So basically P is that matrix which is the combination, which is basically these vectors are span of the matrix. The reason is that every matrix of eigenvectors is basically independent set. Right? Independent set is basically spans of any combination. So we can written as this matrix in some vectors of the mat in matrix form. Right? So this is the basic procedural way you can find out the eigenvalues, eigenvectors of any square matrix. Right? Hope you will enjoy this video. If you enjoy this video,